Hi guys and welcome to Learn Extra Live. It's a Monday, that means it's maths and grade 11, so it is finally your turn.
Yay.
I know that they were obviously watching the grade 10 show because that's what good grade 11s do.
Absolutely, I think so.
They learn more and they learn extra. How are you, Dina?
I'm well, and I'm ready for the trig graphs for today with grade 11s. We're going to make sure that you know everything that needs to know about period, range, domain, translations, horizontal, vertical, all those good things about trig graphs. So stay tuned because at the end of the lesson, you would have learned a lot extra.
That's awesome. That's exactly what I want to hear, they want to hear, and I think that's why we are all here, right, Dina? Okay, so take your spot at the board and I'll
Thanks.
do my little thing. So what I want to tell you guys is that you need to be chatting to us on Facebook. It's facebook.com/learn extra. And the great thing about this is that you can post any questions that you're not understanding on the page. You can help other learners out, post inspiration, study tips, anything. And what this could get you guys is this awesome Casio calculator. We give one away to grade 10, a grade 11, and a grade 12. So there's a pretty good chance this could be yours today. And we are posting the winners from last week up on the page, on the Facebook page. So keep watching that. You can also chat to me on Twitter @LearnExtra. So if there's anything you need, guys, I'm here to help you out. I'm between you and Dina, and this page is not only for us, well, it's not only for me, I'm trying to say, it's for all of us. So without further ado, I want to give a big shout out to Liberty and say you guys rock. Thanks for making this show possible. And Dina, I think it's time I stop talking and you start teaching. Take it away.
Thanks so much, Indy, and it's lovely to be with you again. And as I said earlier, we're going to look at trig graphs. And I thought instead of giving you all the theory, we would just look at an example and extract all the theory that we should be able to know out of that example. And then thereafter, we'll do a couple more drawings of particular graphs with their particular features as a result of the transformations that they've undergone. But let's look on the board and let's have a look at the given example. Right, we're told that given on the picture above is the graph of f of x, and it's equal to cos x, and it passes through the turning point P, which has got coordinates a, b. So if we look carefully at this graph, it's been given a label. We've been told that it's the graph of f of x equals cos x. So it is a parent graph because it's got no coefficient of the ratio, no coefficient of the angle. It hasn't been translated up or down, and it hasn't been translated left or right. So it certainly is the parent graph. And as part of our theory, we should be able to know what are the basic features of that parent graph. And I think they're actually highlighted by the picture. So what we would have is at 0 degrees, if this was 0 degrees, we would have a maximum value of 1. Then the cos graph would travel by decreasing all the way to this value here, which would be 90 degrees, and that would have a 0 value. Your cos graph continues to decrease until it reaches this value here, which would be found at 180 degrees, and that would be its minimum value of -1. And then so it was decreasing until then, and now it picks up, it increases all the way to 270 degrees, and we then end off at a maximum of 360 degrees. So this pattern, or this cycle, that starts at 1, goes through 0, travels to -1, through 0 again, and back to 1, it will now repeat itself all the way to 450 degrees, all the way to infinity. And it will also repeat itself on this side here as it travels to -90, and it goes all the way to -360 and beyond as well. So the cyclical nature will keep on repeating itself. And for it to get from a 1 to another 1, it takes this graph 360 degrees. And that 360 degrees is what we call as the period of the graph. It is how many degrees does it take for one cycle to take place. So if we started at 0 and we went all the way to the next 0, it would take you, actually a 0 is not a very good idea, but a -1 would be from a -1 to another -1, it would be 360 degrees. The zeros are not periodic over 360 degrees. The zeros are periodic over 180 degrees because it takes 180 degrees for every zero to reappear. So the period of the cos graph of y equals cos x would then be equal to 360 degrees. Okay, so the features of the cos graph, simply at 0 we've got a 1, we go decreasing to 0, decreasing to -1, 0, 1, and so if we weren't to plot any function of the cos graph, we would plot it that way. So let's have a look at some of the features as a result of some transformations. Firstly, they would like to know what would the values of a and b equal, and if we looked at a and b, since it's the parent graph, we would now have that this is actually the minimum value. So we would have a minimum, and this minimum is happening at -1, and therefore the coordinates here would be the x value, which is your angle, so it will be 180 degrees, and the y value would be -1. So those would be the coordinates of our minimum. Further, we would like to know how would the coordinates of P change if we were now sketching the graph of g of x is equal to 2 cos x? What changes? What is the effect of having the coefficient of cos x? What happens? The next question is, what would happen if we wanted to sketch g of x, and we would now have g of x equals cos 2x. So in this case, we have the coefficient of the ratio as a changing parameter of the ratio. And over here, we have the coefficient of the angle. What will happen if you double your ratio? What will happen if you double your angle? How will that affect the graph? And then we would like to know, in fact this one's been written as g, so let's just use the same notation. This would be an h of x is cos 2x, give the period of h. What would the period be if you have a change in the coefficient of the angle? So these two things are connected. There's some kind of thing happening here that if I change the coefficient of the angle, that something's going to happen to my period. There must be some connection between these two. And finally, we would like to look at what happens if we have this new function k of x, and k of x is the function where we have cos x minus 2. And we'd like to know what is the transformation that takes place in order to get this new graph. So some connection there. What transformation do we see? And then finally, we'd like to look at P of x as the cos of x minus 30 degrees. And again, right, and we'll stop there because this is a different function. So here, to look at the difference, we have a constant as a term with a cos function, whereas here we've got a constant as part of the angle. So there's a translation happening around the angle. Constant is inside the bracket, whereas here the constant's got nothing to do with the angle, it's just a constant attached to. So we could actually rewrite this as minus 2 plus cos x. That would be the same thing. That would be the same function. All right, so we've seen those 4 different transformations. Coefficient of the ratio, coefficient of the angle, And then if we are adding a constant to the ratio, or if we are adding a constant to the angle. So there are 4 very different looking equations. So therefore we're going to see some very different things happening on the graph. Let's go back to the graph and let's do some discussion. Right, the first one is what happens if we've got 2 cos x. Okay, well simply what we currently have is we have a y value of 1. So if you now say, let's take, for example, y equals 2 cos x, what we're saying is that if we had a 1 over here, we want to take that value of 1 and we want to double it. We want to multiply it by 2. So what's going to happen to this value is it's just going to go up. A 0 will stay the same, whereas this minus 1, if we double it, we're going to get a minus 2. Here we're going to get a 0, and if we double it, we're going to get a 1. So let's do that and see what happens. We're going to get a 2. We're still going to get a 0. We're going to come down to minus 2. We're going to go to 0, and then we're going to go back up to 2. So in the end, our graph is going to do this. Oh, got lost there. Let's just erase that a little bit. Just erase that. And we get up to there. Right, what do we see has changed? So something to do with a coefficient. We've got a doubled value of y. So it seems that that graph stretches vertically, okay? And the distance from the maximum now to the x-axis, this distance becomes double what it was. This distance to the x-axis is double, that distance is double. So the coefficient of the ratio basically doubles the amplitude. Okay, and we can see that from the maximum to the x-axis, from the minimum to the x-axis, from the maximum to the x-axis, that's all been doubled. So if you were to sketch, now we can give some predictions. If you were discussing what 3 cos x would look like, then we would multiply the 1 by 3, so it would triple that amplitude. The amplitude would now be 3, so our graph basically stretches vertically. Okay, so that's the coefficient of the ratio. Let's look at what would happen if we double the angle. So we go back to the graph, and we double 90, we would now get 180. So at 90 degrees, you're actually plotting what your 180 degree value was, which was minus 1. So at 90, you're actually plotting a negative 1. At 180, you're going to be plotting what was happening at 360. So you're actually bringing that graph almost inwards. You're stretching it, or compressing it, should I say. So that instead of getting a cycle to 360, you're going to bring everything forward, so that cycle is actually going to be over 180 degrees and not over 360 degrees. Okay, so it's becoming a little bit messy to actually draw on this one. So I'm going to draw another one. Just down here. So if we had the parent graph, which was that to 360, we would have your y equals cos 2x as a compressed version of this. So here we would have that much. Here we would have actually we would have about 45 there. We'd have minus 1 there, and then we'd have a 0 there, and we'd have a 1 here. Let's just get the spacing right. So you would get something of the sort. So everything is happening a little earlier, so that you'd actually get 2 curves of this graph in the 360. So that's about the 180 degree mark. So there's one cycle to 180, and there's a second cycle to 360. So this really, what I'm seeing is that it gives me how many cycles I would actually get in that period that is usually 360 degrees. I've actually got to get 2 max to max, max to max in between 360 degrees. So if I had cos 3x, if we just make a prediction, what would happen to cos 3x? We've actually got to get 3 cycles in the 360. So we're going to get one, and we're going to get another one, and we're going to get another one, which means that our period has changed. This yellow graph's period, if it's got 2 cycles, it will start there and it will stop there. So its cycle, or it will repeat itself there, it doesn't stop there, would be 180 degrees. And in another 180 degrees, I'm going to get another cycle. So the coefficient of the angle, because it compresses the graph, it will actually always affect that period. And the period is affected, if this is 180, we could say that the parent graph has a period of 360. The new graph, or the transformation, the transformed graph, will have a period that is 180, which is really 360 divided by 2. So if we take these 2 values, we can see that's the period of the parent graph, that's the coefficient of the angle. So the period will change with respect to knowing the period of the parent and knowing the coefficient that you're working with. So with cos 3x, we could predict what the period is, because the period in this case would be the parent's period divided by the coefficient of x. Okay, so to go back to the question, the coefficient of the angle will affect the period. How will it do that? Is our question. It will affect it by the period of the parent graph divided by the coefficient of the angle. That's standard. If you want to work out the new period, what's the period of the parent? Divided by the coefficient. So in this case, it would be 360 divided by 2, which means it's 180. Another way of checking is to make sure that there are 2 cycles in that 360 degrees. So we just compress everything, make it happen a little earlier. Right, then what happens to the coordinates of P? Remember, P we were working with was AB. What happens to the transformation if we now adding minus 2 to cos? Well, we'll go back to the graph. Go back to the parent. What happens if I take 1 and I minus 2? I go 0 minus 1. So what was happening over here is now going to happen at -1. I've come down 2. What was happening there is going to go down 2. What's happening there is going to go down 2, etc. So this whole graph will be translated down by 2 units. That's all that happens. You go to all what we like to call, these are called our quadrant angles. Because if we work with them, we can adjust them accordingly to the transformation and be able to get the new graph. So you don't have to sit there and point plot. You just go to quadrant angles and you adjust the quadrant angles. So it's the parent graph which you lower by 2 units.
Dina,
Okay.
should we take a little
Yes,
break?
let's take a break.
Okay, guys, you can see how much Dina just loves teaching. She just carries on. And if I didn't take a break, she'd probably be here until the end of the day, which I'm sure you wouldn't really mind, would you? But we all need a break, so that's what we're going to do. And we'll see you now as soon as we get back.